That's how we're getting on. So we're going to go through the dip, strike and stratum there as quick as we can. So there's one page that we said we leave till Monday, and that's on the boreholes. And I was looking over it again. Look, there's 5 questions here, 6 for somebody that we're missing. So look, if we get the 6 questions done in these 2 sheets, I'll be happy enough with that. We can get boreholes and hopefully slope roads kind of covered then next week. And that'll be as good as we can get. So again, we went through it in class today. What are boreholes? What is the dip, strike and stratum? So basically, the dip, strike and stratum is an outcrop of ore like we have here. So A, B and C are on the edge of the hill. There are outcrop points that touch the edge. And it's basically saying that this surface here has some valuable ores or rock or whatever it is on it, and it's kind of like a scan they do with the ground to find that. So what we have to do then is we have to find it down here. We have to draw its elevation, and then we have to get the dip, which is the slant it's at, and we have to take an auxiliary to do that. So the one thing, there is a thickness in our stratums, and it'll look like this on the side. The top is our head wall, and the bottom of our stratum is our foot wall, okay? So we have our head wall and our foot wall. Just that we're clear on that, just that we understand that. So if we if we understand that, that's about the height of it. There really isn't a massive amount in this. Now, as I said to the girls today, it's similar enough there's a lot of similarities, I suppose, between this and our coordinate geometry in the sense that we're used to taking auxiliaries and that kind of thing. So what we're going to do is we are going to connect up A, B, and C. And again, I'm going to go through these quite quickly to keep the video short. But you can obviously pause the video and slow it down. So if we look at the question, and I don't know, are we able to see that? We are. So it says the contours are 10 meter vertical intervals. Again, we'll underline that. The only thing is, again, here we'll be using the scale. So I said to the girls today, if it's 1 is to 1000, it's the same as 1 is to 1. If it's 1 is to 2000, it will be like saying it's 1 is to 2. Okay, so because it's 1 is to 1, 1 is to 1000, 1 is to 1, the gaps in the contours are 10, we're stepping up a height of 10. So if we look here, point C is on the 80 contour. Point B, if we follow it around, oh sorry, I'm out of shot there a little bit. So point C is on the 80 contour. So be careful, it's above 70, but it's on the 80 contour. Point B is on the 90 contour. Look, if we follow the 90 contour around, point B is on that contour, and point A, we'll follow the point A contour all the way down and around. Point A is at 110, okay? So we need to start at 80 and go all the way up to 110. So it's the exact same as drawing our soil profiles. So we go 80, 90, 100, 110. Okay, and then we'll pop up our T-square and we'll project them all across. So we'll start with C is at 80. A is at 110 and B, we said, is at 90. So I'll just project them all up that far. So it's like drawing our soil profile. So here's A, here's C, and here is B. Very similar to our soil profiles. Nothing too complicated there. Start of this is very easy. And I'd expect us all to be able to fairly get that. And again, you don't really have to understand what this is like in real life as long as you can kind of picture it here. So that's kind of like getting our true shape now. So we've kind of drawn our true shape. So the next thing we need to do then obviously is get our, as we would call it in maybe if it was between 2 laminar planes, our common line or our true length line. So to do that, we have it's same in laminar planes and intersecting planes. We have to project a line from one corner to another side. Okay, so I could the only option really here is to go from B, the horizontal line, until it hits the line AC. And then I'll project that all the way down until it hits AC down in my plan. So this is an elevation. Sorry, I should have maybe cleared that up. Down in my plan now. And all I'm going to do is where it crosses here, we'll project that all the way through B. And then we're going to take an auxiliary view that is perpendicular to that pink line. Okay, so again, nothing that we haven't actually seen before. So again, we just drew our horizontal line here. We projected down our horizontal line, and now we're going to take an auxiliary to that horizontal line, which will give us an edge view. Okay, so I will go about now drawing my XY. making sure that it is 90 degrees to that pink line. There's our XY. Then all we're going to do is project the 3 points out. Lovely, out they pop. And I'll extend them on through. So think about auxiliaries then. Where do we take our views from in an auxiliary? What are we always saying? Where do we take our views from in an auxiliary? Where am I going to go to get my, sorry, not my views, I should say my distances. Where am I going to go to take my distances? So correct, I'm assuming you all said 2 views back. We're going to pop 2 views back to take our distances. So I'll start up here at A, measure down to the base. Now you could start from the 80 contour if you want, and that would just mean that C would be on the base here, so it wouldn't matter. So you can do that any way you want. But I'm going to show, I might have to show you a little trick now here, because I'm guessing my lines aren't as parallel as I'd like them to be, and that they're not probably going to add up, but they might do. So there's our distances transcribed. So there's B, sorry, there's A, there's B, and there's C. And there's our edge view. So our edge view, these 3 points should always connect up in a straight line like mine are going to do there. If they don't, obviously just doctor the middle point to make sure that they do. All the way back like that. And then this angle right in here, that is going to be our angle for the dip. Okay? And that's it. That is all there is to it, lads. It's as simple as that. And that is how you finish that is how you finish that question. Like, that is literally all there is to it. There's no more. So yeah, we can label this maybe as our true length, probably good practice. And that is what we call our strike. So our true length is our strike. I should have cleared that up. I apologize for that. So there's our stratum up here. There's our strike there, and here's our dip here, which is the angle that our stratum is at from an edge view. That's it. That is your dip, strike, and stratum. So we'll go through the next question. So I'll try and speed up a little bit now. Just the camera doesn't disconnect here now. I'd be ripping. Just so that yeah, look, the video's not too long. So again, ground contours are at 5 meter vertical intervals. A, B, C, and D are outcrop points. Head wall of stratum, more D is, and so we have foot wall and head wall in this. Okay, did we have foot wall and head wall in the last one? I don't think so. Nope. So we're going to have to do our thickness now here as well. So again, determine the dip, strike, and thickness of the oars. So thickness is the new one here. Ratio is 1:1000, which is 1:1. Gaps is 5. So we are going to step out 5. I should make sure this isn't too dark without the lights. No, we look okay. That looks visible enough. Yeah, lovely. Okay, so we're going to do the same thing again anyway. We're going to find out what A, B, and C are on, what contours. So A is on 80, C is on 95, and B is on 75. So we have 75 up to 95. And we're measuring up 5. So we have 75, 80, 85, 90, and then 95. Stuff. Bring them straight across. Just like that. We'll bring all these boys straight up. So B is at 75, C is at 95, and A is at, what did we say was at 80, so 75, 80. 85, 90, 95, yeah, lovely. A, C, and B. Lovely stuff. So again, if you're looking, there's only one place it makes sense to do our horizontal line here, and that is from A to line CB. Lovely, so across it comes. We can project it all the way down to where it hits CB, which is just there, and now we project A all the way out through that point, just like that. And then we'll draw our XY line perpendicular. Project our lines out parallel. And take our distances from 2 views back. Where did I leave my compass? There it is. A, B, and C. Lovely. So there is C, there's A, and there's B. Lovely. So again, nice and quick. That's that question almost done, except for one thing. So it says we have to also get the thickness, and it says the head wall of a stratum of ore D is an outcrop point on the footwall of the ore. So how are we going to do that? So if we look at what contour line D is on an 80 contour line. Okay, so what we're going to have to do, we know point B is at 75. We know point A is at 70. So a quick way of doing this is we'll just project across point A like that and project point D out parallel until it hits that there. And there is our footwall. Okay. And it's as easy as that. So what you might have to do in another question is like up here in our, just let me make sure I'm definitely visible. Yeah, it's a bit dark, but we're okay. Like up here, that we have our contours drawn out, our lines drawn out. Sometimes you might have to draw your lines out here. If this was on, say, 85, we wouldn't have an 85 line. We'd have to draw it out, but you get the point anyway. Like I might have to go 5, 5, 5, 5, bring them all across to get the point. So yeah, there you go. So there's our head wall, and I assume the next question is going to be, there's our foot wall, and I assume the next question is going to be head wall, which means it's above. We always assume then that the head wall and the foot wall are parallel. So there you go. There's our head wall, and there's our foot wall. H and F. Lovely. So we'll go on to the last one now, and I'm assuming that that is going to be looking for a head wall instead of a foot wall. Nope, foot wall again. Lovely stuff. So we will try and get this done nice and quick before my first years come in here and rampage the room. So again, we have A on 70, B on 100, and C on 80. So we're going from 70 up to 100. Scale is 1:1. Gap is 10. 80, this is definitely 70, and that's definitely 100. So we have 70, 80, 90, 100. Same thing again. And again, slow me down on the video if you need to. All the way across, all the way across. Again, why did I mark them here, not at the very edge? Because I know that my triangle crosses here. So A is at 70, which is the bottom line, which is projected up to there. B is at 100, we'll project it all the way up to the top. And C is at 80, which is the second one up just there. Lovely. So we have A, B, and C. We'll connect them up like that. Again, the only place it makes sense to do a horizontal line from here is C. How do I know that? Well, because the horizontal line has to come from a point and hit a side of the triangle, and it has to come horizontal. Horizontal from here, we're not hitting any side of the triangle. Horizontal from here, we're not hitting any side of the triangle. So there's that there, and we always project it down then to where it crosses. That's going to be an interesting one now. I hope I'm not gone wrong there now. My strike is probably down a little bit low. It probably shouldn't be down as low, but it's not the end of the world. So again, now I can go down here or I can go up here, and I'm going to go up here because they've given us the space up there. So I'm going to go up there. I'd say my strike is a little bit far down. We should always label that as a strike as well, by the way. Sorry. Lovely. So we'll draw our auxiliary at 90 degrees to that there. And we'll bring our points up parallel. And up parallel. Take our distances from 2 views back. So we'll mark off A. Mark off B. Mark off C. And again, it should give us a lovely little straight line view. See, just about up there. And again, we'll always label them as A, C, and B. The foot wall is at a height of 80. So we'll project it out there parallel. Out it comes like that. Are any of our heights at 80? A is at a height of 80, so we know it's going to be straight line with A. We'll bring A all the way across till it hits, which is right there, and then we'll draw a parallel. So this one is a good bit thicker. And again, we label them as H and F. Okay, so that is the basics of that, lads. And again, just what I was saying about the head wall and foot wall here, right? So if we didn't have the height of D, right, we project line D up, and then we go, right, there's 70, there's 80, there's 90, there's 100, and we project all these across like we do in our soil profiles until we get the height that it's at. But we know it's at 80. That's just a clever way of doing it. If it's on one of the contours, which a lot of times it is, a lot of times it won't be. But just if it's not, you'll have to project up your heights like we do in our soil profiles. That'd be 70, 80, 90, so on and so forth. I know that was quick enough, but I'll upload the second video now soon enough as well. I just want to try and keep it quick enough. But again, if there's any questions, lads, private message me, comment, whatever it is, and I'll have the second sheet up later on then today, okay? So just give that a watch and see what you make of it.
Hello.
How are you, Millie?